Hi students, have a nice day. In this section we are going to discuss about the naming of polyfunctional groups and nomenclature or naming of aromatic compounds. In the last section we discussed about the naming of functional group. When a OH group comes, we add the suffix "ol". When a aldehyde groups comes, the secondary suffix is "al". And carboxylic acid COOH group comes, the secondary suffix is oic acid. Then in this section we are discussing about the compounds which containing polyfunctional group. What do you mean by poly? Poly means many, more than two, okay, or two or more than is called polyfunctional groups. Okay, let's discuss some points. If polyfunctional groups are present in the molecule or more than one functional group present in the molecule, we select one of the functional group as a principal functional groups. Okay, so many functional groups in the molecule, we select the principal functional group according to the order. Okay, the order of the principal functional group is order of functional group. If COH is present in the molecule, you give the priority to the COH group, carboxylic group. Then SO3H, sulfonic acid. Then ester, COOR, where R is the alkyl group. R means alkyl group. Methyl, ethyl, propyl, isopropyl, like that. And next priority is given to acid chloride. Okay, acid chloride. The next priority is given to acid amides. CONH2. Okay, Cl is acid chloride. Then CONH2 is acid amide. The next priority is given to cyanides or nitrile. Okay, nitrile is the secondary suffix. The family is cyanide group. Then comes CHO, aldehyde group. Then ketonic group, C double bond O, ketones. Then alcohols. Okay, alcohols. Then amines. Then C double bond C, C triple bond C. So if many functional groups are present in the molecule, we select one of the functional group as a principal functional group. The other groups are treated as substituents. As you know that substituents are prefixed. Okay, main functional group or principal functional group decides or determines the secondary suffix. The other functional groups is considered as substituents. Substituents are prefixed. Okay, then other substituents, the alkyl group. R is alkyl group. The functional group halogens. What are different halogens? Fluorine, chlorine, bromine and iodine. Then nitro group, NO2 group, nitro group. Then alkoxy group, OR group, alkoxy group. Then C6H5, phenyl groups. These groups are always prefix. Even though they are functional group, halogen is a functional group, nitro group, alkoxy group. These are functional group, but we write these groups as prefixes. Okay, alkyl group, halogens, nitro group, alkoxy group, phenyl group. C6H6 is benzene. Then similarly alkyl group we treated as phenyl group. These are always prefixes. These are suffixes. If the molecule don't have any COH group, you check whether the molecule contains the other functional group SO3, HCOR, COCl, CONS2, CN, CHO, then C double bond O, OH, NS2. Okay, so it's clear when we discussing some problems, some examples. Okay, so let's discuss some examples. Can I draw the bond line structure? It is easy to understand the molecule. Okay, the first one is and one more point is select the longest carbon chain, hydrocarbon chain, which including the maximum substituents, maximum functional group. That's very important. If more than one functional group is there, we select the longest hydrocarbon chain which including all the functional groups. Okay, so that is very important. So here OH is a functional group, halogen, chloro is a functional group. Then select the longest continuous carbon chain which including the functional groups. So 1, this is the first carbon, 1, 2, 3, 4, 5. Okay, and remember that the principal functional group is OH. No other groups present in this molecule. So the order you should keep in your mind. The order is, okay, you should learn this order. COH. If there is no COH, you check whether the molecule which is having SO3H. Then if these two are absent, you go through, check this one group. Okay, if these three groups are absent, you check whether the compound or molecule contains COCl. Then successively you select the principal functional group. So in this case, the principal functional group is OH. And halogen. Halogen, even though halogen is a functional group, it should be written as prefix. Okay, so what is the name of this molecule? 3-chloro. Third carbon atom contains chlorine. So 3-chloro, 1, 2, 3, 4, 5. Pend 1-ol. Pentan 1-ol. Since the molecule is saturated, we use the primary suffix ane. And while you are adding the secondary suffix, you know the rule. Secondary suffix is started with the AEIOU. The E of the primary suffix is dropped. The position of the alcohol group is 2. Okay, so the molecule is 3-chloro-pentan 1-ol. Another example. Okay, CHO, CH2, CH2, CHOH, CH3, CH3. Here two functional group is there. What are the two functional groups? CHO. Okay, CHO is a functional group. OH is also a functional group. According to the order of preference, order of priority, which giving or which get the priority, aldehyde. Okay, aldehyde and alcohol is present in the molecule. According to the priority order, this is the priority order of the functional group. CHO is more prior than the priority is given to the CHO group. Then we can number 1, 2, 3, 4, 5, 6, 5, 6. Any order you can choose. Okay, 1, 2, 3, 4, 5, 6. Select the longest hydrocarbon chain which including the all the functional groups. So CHO is included in the chain. OH is included in the chain. Okay, then what is the name of two substituents? This is principal functional group. OH is substituent, even though it is a functional group, then methyl substituent. So what is the name? We should return the alphabetical order. Okay, we should write it in the alphabetical order. OH group, when it is prefixed, OH group is hydroxy. So 4-hydroxy, 5-methyl, hexanol. Okay, and some students have doubt, sir, why it is not a hexan 1-al? Because the aldehyde group is present in the first position. Remember that if aldehyde group is a principal functional group, the first number, the number 1 is given to the aldehyde group. That's why we don't write the position in the case of aldehyde. Okay, sometimes we write, that is a special cases. You will learn it is in the +2 classes. So usually in the case of aldehyde, the position not mentioned because the CHO group is in the first position. Are you clear? In the case of aldehyde group, the position not represented because it is always at first carbon atom. Okay, that's about the group contains the polyfunctional group. One more example. Remember that you keep this order in your mind. It is given in the textbook. You memorize it always. It is in the fingertips. Okay, it is in the fingertips. You can write the name very fastly. Okay, another example. Another example for polyfunctional group is, okay, one example I written the condensed formula CH3, CH, CH3, C double bond O, CH2, CH2, okay, one more, COOH, COOH. Here the functional groups are carboxylic group, ketone group. Okay, two functional groups are present and one substituent. So out of the carboxylic group and the keto group, which group get the priority? Carboxylic group. According to the priority order, carboxylic group will get the priority. So that carbon is obtaining lowest number. Okay, so 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Then, so here the keto group is a substituent. Then substituents are prefixed. If keto group is a substituent, the name is oxo. So oxo O, methyl M. Okay, so which is in the alphabetical order, M comes before O. Okay. So 4-methyl, 3-oxo, 4-methyl, 3-oxo, 5 carbon atom, so pentanoic acid. Pentanoic acid. Pentane is the parent chain. 1, 2, 3, 4, 5. Okay. 5, 4, 5. Both are same. So pentane is the parent chain. So oic acid is the secondary suffix. While you adding the primary and secondary suffix, if the secondary suffix is started with the vowel E of the primary suffix, that is E of the ANE, ENE or YNE is dropped or removed. That's why it is 4-methyl 3-oxopentanoic acid. Okay, another example, CH3, CH2, CHO, single bond, CH double bond, CH, COOH. Another example. Okay, so here the functional groups are carbon double bond carbon atom, COH group, CHO group. Okay, COH group, CHO group. The priority is given to COH group. Okay, priority is given to COH group. Then we can number from this carbon atom. Okay, 1, 2, 3, 4, 5, 6. That's the longest chain. Okay, 4, 5, 6. This is the longest chain, and that chain contains all the functional groups. COH functional group is in the chain. The double bond is in the chain. CHO functional group is in the chain. So this is the longest chain. And when the CHO group is considered as a functional group, secondary suffix is al. But this group is considered as a substituent. The name is 4-mile or 4-mil or sometimes oxo. So 4-mile M. No other substituents. So the name is 4-mile. 6 carbon atoms, so hex, double bond in the second position, so hexa 2-ene oic acid. Okay, 4-mile, fourth position, 4-mile group. Then second position, double bond, and COH is always at the first position. That's why we not mention the position of COH group. So that's why the name is 4-mile hexa 2-enoic acid. Okay. Next we discuss the naming of aromatic compounds. Aromatic compound means benzene and substituted benzene. Benzene is the parent chain. Okay. So the functional groups are usually prefixes. Okay. The derivative of benzene, the functional groups usually prefixed. Okay, let's discuss some examples. Benzene. This is benzene. This is the parent chain. Parent chain. Then if one methyl group is present in the benzene, CH3, one methyl group is present in the benzene, it is called a methyl benzene. Methyl benzene. It is the IUPAC name. And its trivial name is toluene. Toluene is the common name or trivial name. I remember that this name is accepted by the IUPAC organization. Okay, IUPAC organization accept the name toluene. Another one is when OH group is attached to the benzene ring. OH group attached to the benzene ring, it is called hydroxybenzene. Hydroxybenzene. And the common name is phenol. Phenol is the common name. This is accepted by the IUPAC organization. This is the correct IUPAC name. IUPAC name of the phenol is hydroxybenzene. You remember that phenol is accepted by the IUPAC organization. Another is when NH2 group is attached to the benzene ring. It is aminobenzene. Aminobenzene. Sometimes it is called a benzenamine. This is IUPAC name. So IUPAC name is aminobenzene or benzenamine. And the common name is aniline. Aniline is also accepted by the IUPAC organization. Okay, so the name which is expressed in the bracket is common name or trivial name. Some names are accepted by the IUPAC organization. So methyl benzene is the IUPAC name of toluene. Toluene is also accepted. Then when OH group in the benzene ring, it is phenol. The common name or trivial name is phenol. The correct name is hydroxybenzene. Then if NH2 group is attached to the benzene ring, it is aminobenzene, and its common name or trivial name is aniline. Similarly, some other molecules. Okay, let's discuss more examples. Hope you understand this. Another, halogens and nitro groups are present. Halogens and nitro groups are present. Cl. It's chlorobenzene. Chlorobenzene. When bromine group comes, okay, all the 6 carbon atoms are identical. So Br comes, it is bromobenzene. Bromobenzene. If iodo group comes, iodine comes, iodobenzene, fluorine comes, fluorobenzene. Okay, so that's is. Then when nitro group comes, wherever the functional group comes, all the carbon atoms are identical, so no need to write the position. If 2 or more functional groups or substituent present, you should number the chain. Then this is nitrobenzene. Nitrobenzene. Okay. You can use capital N, no problem. Nitrobenzene. Okay. Then another is when OCH3 group. OCH3. Methyl and one oxygen. So methoxy group. The correct IUPAC name is methoxybenzene. This is IUPAC name. And its common name is anisole. Okay, anisole. Anisole is the common name of methoxybenzene. So we have seen the IUPAC name as well as common name. Some common names are accepted by the IUPAC organization. And another important thing, if 2 substituents or 2 or more substituents comes, how we write the name? Okay, so in that, common names and IUP names are somewhat different. For example, 2 chlorine atoms are present in the benzene ring. 2 chlorine atoms are present. The IUPAC name is 1, 2. 1, 2 dichlorobenzene. 1, 2 dichlorobenzene. The common name is orthodichlorobenzene. Orthodichlorobenzene. Okay, so 1, 2 position. 1, 2 position is ortho position and is represented by O. Okay, ortho position. 1, 2 position in the benzene ring is called ortho position. And this isomer, chlorine, chlorine. Okay, due to resonance, these pi bonds are delocalized or resonating through the ring. You remember that. This is 1, 3 dichlorobenzene. 1, 3. 1, 2, 3. 1, 2, 3. Okay, in both direction, same numbering. Okay, identical position. And its common name is, or trivial name is, meta, M-dichlorobenzene. M-dichlorobenzene. Okay, M-dichlorobenzene. What is M? M means meta. And the meta position is 1, 3 position is meta position. 1, 3 position is meta position and is denoted by small m. Not capital M, small m. Another. Cl and the opposite carbon atom, another Cl atom. This is 1, 4. 1, 2, 3, 4. 1, 2, 3, 4. Both numbering is correct. So 1, 4 dichlorobenzene. 1, 4 dichlorobenzene. And its common name is para-dichlorobenzene. Para-dichlorobenzene. And 1, 4 position is para position. You remember that. 1, 4 position is para position. Okay. 1, 4 position is para and is denoted by small p. Okay? Yes. And this is concluded. Okay, let's conclude the position in benzene ring. Okay, this is the benzene ring. If one functional group, the principal functional group is present in this position. This is the functional group. With refer to the functional group, okay, with refer to the functional group, the adjacent position are ortho position. Okay, 1, 2, then if one atom present in this position, it is also ortho. Okay, 1, 2, 1, 2. And these two positions are meta position. 1, 2, 3. Okay, 1, 3 position is meta position. And this opposite position is para position. Okay, the opposite position is para position. Okay, you understand this. Memorize this position. 1, 3 position is meta. Sorry, first we have to say about the ortho. 1, 2 position is ortho. 1, 3 position is meta. And 1, 4 position is called para position. So in IUPAC nomenclature, we write the number, position number. In common name or in trivial name, the positions are either represented by ortho, meta or para. Okay, one more example. Already we heard about these two examples in the hydrogen bonding. Okay, so I erase these things. You study orthonitrophenol and paranitrophenol. What is a phenol? In benzene ring, the OH group comes, it is phenol. Okay, OH group comes, it is phenol. Then the ortho position, 1,2 position. The common name of the molecule is orthonitrophenol. Okay. Orthonitrophenol. And what is the IUPAC name? What is IUPAC name? 2-nitrophenol. Okay, this is IUPAC name. Another one. NO2 group. Then OH. Principal functional group is OH. Two functional groups are there. Principal functional group is OH. That's why it is phenol family. Then 1, 2, 3, 4. 1, 4 position is para position. So paranitrophenol. Use the first letter as a capital one. Paranitrophenol. Okay. Then IUPAC name is 4-nitrophenol. 4-nitrophenol. Since the groups are adjacent, in this molecule, intramolecular hydrogen bonding and it has low BP. In this case, the functional groups are far away. And that's why intermolecular hydrogen bonding. Hydrogen bonding is between two molecules. Here within the molecule, in this case between the molecule. So intermolecular hydrogen bonding, the boiling point and melting point is higher. So as comparing the boiling point, low boiling point, higher boiling point. And these two are separated by steam distillation because orthonitrophenol is steam volatile. Okay, when steam is passing through the mixture, orthonitrophenol with a low BP, it's a steam volatile, it comes out fast. And that's why steam distillation can be used. Okay, so these are some important examples which contains polyfunctional group. So today we discussed about the nomenclature of molecules which contains polyfunctional group as well as aromatic hydrocarbons. Okay, in the next section we will discuss another concepts. Thank you.